Hi students, welcome to the session on step response of LTI discrete time system. See, this is a very important concept. We already know about impulse response. What is impulse response? Right, we have inputs x of n and output y of n. When input is del of n, what we get in the output is impulse response h of n. Right? Similarly, what is step response is, see, impulse response means we have given impulse signal as the input. For step response, we have to give step signal as the input. What we get at the output is step response S of n. So this is impulse response. This is step response. Okay. So the step response is a response of the system to the unit step signal. Simple logic. Okay. So we know that any LTI system, the output is y of n, that is equal to x of n star h of n. When when x of n is u of n, that is when you give input as the unit step signal, what you get at the output is step response. Right? So this is the thing. So when x of n is u of n, what you get at the output is s of n. This is what step response equation. Okay, so this I can write as summation k goes to minus infinity to plus infinity, right? H of k u of n minus k. Convolution equation that we know, simply we write x of n h of n, write as k goes to minus infinity to plus infinity x of k h of n minus k. No, the same logic, but I used commutative property. So this is like h of k x of n minus k. Instead of x, here we have in step response we have u. So this is what our s of n. Okay, suppose, right? And what is the range of u of n minus k? We know that u of n minus k exists from k is equal to minus infinity to n. Why? When k is minus infinity to, this equation will become u of infinity. When k is equal to n, this will become u of 0. We know u goes from 0 to infinity only. What is the condition? U of n is equal to 1 when n is greater than 0. That is 0 to infinity. At that time only it has value of 1. For all other value it will become 0. So when I substitute k is equal to minus infinity to n, then only it will have a value. For other values it has 0, because u of n will become 0. H multiplied by u 0, you will get 0. So you don't need to go for full limit. You can go for k is equal to minus infinity to n only. H of k, simple. For k is equal to minus infinity to n, u of n is equal to only 1. So I don't need to write. So this is the step response equation. Fine. So if we know impulse response, how to find the step response? By using this formula. Okay. So this is very simple, right? I hope you understand this concept. And moreover, we can write s of n minus s of n minus 1 is equal to h of n. You see, that is a beautiful conclusion. Why? You see that this equation I split into two parts. How k goes to minus infinity to n minus 1 h of k plus h of n. Yes or no? So you see, when n minus 1 plus n, remaining thing is 1. If I go for, so if I make the summation from minus infinity to minus n minus 1, what is the only thing I left? N. That is h of n, right or no? So if you add these two, you will get this one, right? Okay. Now I bring this one to left hand side. This I can write as, for minus infinity to n, I can write as s of n, means minus infinity to n minus 1, I can write as s of n minus 1. So s of n minus s of n minus 1 is equal to h of n. What is the thing? Step response up to n minus step response up to n minus 1 is equal to impulse response. That we know already. Why? See, u of n is going from 0 to infinity. U of n minus 1 will go from 1 to infinity. If you subtract both, what you will get? Only unit step signal 0. Yes or no? Like that, this one will go step response, that is the response of the system for u of n. This is what is the response of the system for u of n minus 1. If you subtract both, what you get? Impulse response. Simple logic, right? So this is another important conclusion of impulse response and step response. This equation relates step and impulse in the most clear-cut way. I hope you understand this concept clearly. If you have any doubt, please ask me in comment section. Thank you.